Carbon forms 4 bonds in 3 dimensions. Sometimes carbon forms bonds with 3 other atoms. When that happens, the 4th electron goes through the middle of the atom, sticking out the top and the bottom. And when it does this, it pushes the other 3 out into a plane. So the 1 electron, half of it's on the top and half of it's on the bottom. This structure by itself is not stable. But if 2 of these carbon atoms are together, the clouds on the top find each other and the clouds on the bottom find each other. And the result of that is that the bond doesn't rotate. So this is a rigid structure. And the important aspect of this is that this structure, these 2 structures are not the same. The bond doesn't rotate. So this guy's not going to turn over to here. If it's this way, it's this way. And if it's this way, it's this way. This one is the trans and this one is the cis. And sometimes you see that in the media. When they talk about trans fats, they're saying that we have the trans variety instead of the cis variety. And we'll get into that later in third rock chemistry. But the overwhelming aspect of the double bond is that the bond doesn't rotate. The clouds are important too. The clouds come up again and again and again. So for visual images, don't overlook. We don't want to overlook the clouds. And then the second aspect of this has to do with energy. The double bond it's like a spring that's cocked just a little bit. So there's tension in the bond. And the result of this is that it takes energy to make the carbon-carbon double bond. The carbon-carbon double bond releases energy when it's broken, which gives double bond a little bit of a flavor that the carbon-carbon double bond is thermodynamically unstable.